Awesome. Hello. Hi, everyone. Thanks for joining. It's March Office Hours. I'm Mike Foster. I'm the Cloud Native Advocate at StackRox, and I'll be moderating this next chat over the next hour with Steve Jager. Steve Jager, who is the Kubernetes Security Advocate at StackRox, too. So we're going to have to expand on those advocate titles in a little bit. But before we start, I just wanted to go over some general rules of engagement. So everything's muted on the viewer's end. It's an on-demand recording, and everything's going to be posted after the event if you miss anything or want to share. So we'll be answering questions throughout the session. So you'll see a little chat Q&A section. Feel free to drop stuff in there as we talk now at the end. Whenever we'll answer it live as they come. If you have any trouble with the webinar console, just refresh the browser. Sometimes it hangs a little bit. Simple refresh normally does the trick. And today, just moving into the topic, it's all about Kubernetes workflow security. So, I don't want to take away too much. I want to introduce Steve and let him get into it. So, Steve, welcome. Tell us a little bit about yourself and what we're going to talk about today.
Yeah, thanks. Thanks, Michael. My name is Steve Jager. If you've seen my name written, that's how you actually say Jager. Very difficult for only 7 letters. And my title, Kubernetes Security Advocate. That is what I'm doing at StackRox. But my history goes kind of way back, which is what we're going to get into today, because we're talking about workload security. And it goes all the way back from before StackRox, working with software composition analysis, static analysis, all the way back to even like threat modeling and pen testing and live, everything you would do from the very beginning of designing your application all the way to the end. So I'm very happy to be here. This is going to be a lot of fun.
Yeah, awesome. You recently did a layer cake talk, so and without giving away too much, I'll let you get into it. But you mentioned 7 layers of security. So from all the way back into Kubernetes, obviously things have changed over the last 30 so years that you've been in the security space. Do you mind talking about what you mean by the 7 layers of security?
It's like an age crack in there, didn't you? It's experience, 30 years of experience. Mm-hmm. Yeah, I'll talk about the layers, sure. And I'm not. These aren't cast in stone. These are just more a way of conceptualizing defense in depth, if you will. So there was starting with the cloud, so the infrastructure, which existed prior to this, as say your data center. The pipeline itself, which is sort of ubiquitous across the entire thing. The application, which people are generally, I like to think they're pretty savvy in terms of security. Maybe I'm being generous there. The application's friends and dependencies, which is a growing subject in terms of open source. The image, if we're talking about modernization and containerization. The way that image is deployed. So the deployment, that's a relatively new concept, which is where we kind of sit at the moment. And then, of course, runtime, which is actually what people associate container or workload security with, but we're going to try and maybe expand that definition today.
Mm-hmm. So 7 layers. And do you see these layers changing in the future?
Everything has 7 layers. That's just that's a fact. I started with the had to be 7, and then I went, well, how do I do this? But to answer your question, do I think it's? Of course, it can change. I'm not even 100% in stone about the 7 that I've got, because I think there's and feel free to comment back on me, right? Being very experienced in cloud native yourself, of course, that area between deployment and runtime, I have questions myself about where, say, network policy fits. It's a declarative definition of what must happen at runtime. It's preventative. It's proactive. And the same thing with, say, things like admission controllers. We have the idea of pre-flight checks to infrastructure as code. We have the idea of monitoring behavior at runtime. But these kind of oddly sit in the middle of whether they are how they are still can be. They represent a declarative level of security, but they are that bridge between layers, right? And I don't know if that's its own layer in its own. Maybe it's like that's 6.5 or something. So someone might come up with a better way of doing this.
Yeah, I also think one of the large holes too is when you get into cloud providers, they also enforce those different layers, with different means, right? If you're doing something like a cloud run or serverless versus a managed Kubernetes offering, right? You're going to have different checks, right, as part of that pipeline and that build up to actual runtime. That's why I thought the layers were pretty useful, because especially somebody who maybe they're just getting into a cloud provider, how do they figure out what they need for their security tools, right?
Yeah, I think so. Sorry, just one more thing I just made me think of, because what you mentioned about different cloud providers provide different means of doing that. I would say there are people who live in the AWS world or the GCP world, or other cloud providers, of course, are available. They might see the cloud. They might see layer 0 and say, Steve, gosh, there's at least 10 layers just in that layer. If we're talking about access control lists or anything like that, but that's not where I'm trying to, I potentially have oversimplified that one layer. It's a vast one.
Yeah, that's completely fair. I guess the question is where do you see some of the biggest gaps from organization to organization, and what is the common ground in terms of identifying those layers?
Well, I think the common ground is the application. And I alluded roughly to that, right? People have been writing applications for, the whole 30 years. Let's just say that, right? I started as a developer in my teens, right? So I was writing bad, insecure code from a very, very young age. And thankfully, the idea of quality came in first. That was where that's actually where my background starts. It doesn't start in security. It starts in quality and craftsmanship and things like that, right? And then that was a natural mutation into security, but people got that early. It's only when we started to move into the idea that now and I think in parallel, data center security was understood. And so I'm probably being generous there too, right? Speaking to some of my data center friends. But those came up side by side and very much siloed. And now we're at a point where those are, let's say, merging into a single entity in terms of security. So while there's a common ground and an understanding within security teams that we need to secure the application, and then there's people in ops who are starting to understand that we need to secure this cloud, what's missing, those are the common areas. What's missing is the idea of how do we bring that all together under a single understanding or a single effort. That's where the mystery lies. That's where the new terminology, which we like to poke holes in, like DevSecOps, emerges. This unicorn.
Mm-hmm. Yeah, and cloud, and in general, these new technologies have been adopted fairly quickly, right? So do you think that the speed of adoption for new technologies also leads to a massive challenge for upper management to how to place security teams? Like if you have an existing security team, you might just say, hey, you need to go learn this, instead of actually maybe re-architecting your security team into something different. Do you see like some friction there?
I think it's on security teams to keep up, because if you were going to opt for the don't just go learn this, let's bring in some people who already get it, you'd be changing your staff churn at this point in time would be relatively ridiculous. So you're going to have to start telling security people to go learn the new methods. Now I lost track. What was the first part of that question? You warned me you'd ask two questions at once. In one.
Yeah, it was more to do about the speed of adoption influencing how security is implemented today.
Well, how security is implemented. Yeah, the speed of adoption is influenced by, generally, to be perfectly blunt, money, right? Cloud is there as an enabler for time to market. And it's taking away elements of your application deployment that are not part of your core competency. It's anything you buy as a service is something that is enabling you to move quickly, and that's why they're there. But it doesn't change. And in fact, it's an absolute nightmare for security, because now security was a game of checks and balances. You could put gates in place, and you could say what you can and cannot do. But now, if everything's based on velocity, security is going to have to start changing their entire perspective on what it means to apply security controls. Be that if it's after the fact, be that if it's an acceptance of risk, because we know that we can deploy and retract an application that we discovered to be insecure by default after the fact. Like, these are new methods that we have to start thinking about as security people.
Mm-hmm. Yeah, it's a tough balance, especially for people to to get into, right? Because I mean, obviously, at the end, computers deliver a service for money, right? And you could get an application up and running in serverless fairly quickly, right? So you used to have to own infrastructure and own the security risk and responsibility associated with that too, right? And now I think a lot of it, the conversation of where the responsibility lies, is also somewhat muddled, because maybe you don't actually understand all of the layers of the cloud that maybe are supported versus not supported, right? And then open source also makes things somewhat more complicated, because then you can have cloud, you can have open source applications on your platform, and you can have your own application. How do you know where the threats are, right? So wanted to somewhat pivot that into a little bit more of a security tooling for a more modern architecture, right? Into like an observability talk of how do you identify something that is noisy versus dangerous, especially when you do have something like a cloud, some open source applications, maybe in Kubernetes, and your application.
Okay, you're making reference to the... for anyone who, if you haven't seen my layer cake talk, you can find it on the OpenShift Commons on YouTube, and you'll see the reference that we're talking about noisy versus dangerous. So I made a reference that I characterized information security, or those people responsible for Kubernetes security, in my talk. And I stated one of the biggest problems they have to deal with is tools tend to fall into one of two categories. This is a perception, not necessarily a reality. I think that's something I need to make clear. Tools that generate a lot of noise tend to be favorable. So if you, in the past, so if you've got something that's monitoring runtime or real-time activity within any kind of application, we can even go pre-Kubernetes or pre-cloud, and you're pushing that, the tendency would be to take everything, all logs, all activity, Kubernetes logs, Linux logs, syslog, everything, punch that into Splunk or some kind of SIEM tool. Other SIEMs are available, of course. And then that's noisy. But there's a warm kind of comfort level associated with knowing that you've not missed any piece of data. Should a breach, so if you think of compliance, or GDPR, should a breach happen, I have all the evidence. There's a certain happiness associated with that, of knowing I've got it all. But then there's a massive difficulty to do with the signal to noise ratio. Like, what really matters in all of that, and how do I create use cases within my SIEM so that I sift through that haystack to find that needle, such that I can start to be preventative, or I can learn and I can provide better security control. So that's where I think of noisy, if I were to define a tool as noisy. And I don't want to poke holes at noisy, but having started in static analysis was notorious for false positives. It was noisy. And finding things that mattered meant people didn't use it because that work was just too hard. I think certainly in cloud security, when you talk about what we're trying to do in terms of characterizing what good versus bad behavior looks like, both for workloads and what they're doing, we can do better in a microservice environment, because by definition, containers are meant to be simpler. So that's good. So we should be less noisy, but I'm not convinced that right now we are all the time, because we often, as security tools, don't design we maybe have a fallback position of, just send it to Splunk, or just send it to Elasticsearch, or just send it to whatever it'll be, and let that expert sort it out, who doesn't even really understand the data that's arriving, right? That's the bad thing about noisy. The flip side of that is, what's a dangerous perception is that someone comes in and is aware of the noise, right? So they're saying, our tool is way better. We're only going to tell you when this really, really important thing happens. And as much as that is just a sweet sound to a security person who has epic tool fatigue, there's like a little kind of devil on the shoulder saying, can you trust them? I've been brought up on zero trust. How do I trust this security vendor to know what is their methods? What is their technique? How have they defined risk? Do they understand my risk? Do they understand my compliance? Do they understand the board members who want me to go up and report above to prove that this silence is good? So that's what gets perceived as dangerous. And The tooling involved could be amazing. It could actually be doing what they say it's doing. That doesn't change the perception as security people that, what if I missed something? What if I only had that signal and yet something else happened and I had no signal? Now I don't have the data. Or do I have the data? Is it somewhere else? Can I go get it? Can I still run my forensics to know how to learn post-breach or post-event? So that's where danger comes into play, and that's that eternal struggle within tooling is finding that middle ground. That signal to noise ratio is a sweet spot that is pretty elusive.
Yeah, and we've also made it somewhat more complicated with microservices where, your call stack comes in out of order too, right? So how do you also triage and organize? And honestly, like you have auto healing, right? So you could have somebody, some sort of malicious attacker, right? How do you go about solving for something like that? That's a tough thing to solve for.
It's a super. Okay, sorry. Go ahead.
No, if you finish your thought, I was going to lead into the next question. So if there's more.
Oh, no. Yeah. There's a real gap in the security market at the moment. Every now and then if people are listening and they want to create tools or products, I'm going to throw a challenge out at you. There isn't a lot out there in there is for malware, but not in our world, in the containerization world. There's very few things that run proper containment. So unless Michael, and I would love to hear it, I don't know anything that when you see an anomalous behavior in a container, and whatever it is, let's assume your definition of risk is good and there's a real bad thing happening. I know of either chaos theory destruction, or I know of a variety of different measures around prevention, right? Or business continuity, let's say. But I do not know of anything that can usher that live container into a sandbox, pop up a new replica, and provide a perfect forensic environment. I don't know anything that does that, and that would be the challenges. The gauntlet has been thrown down to people who want to make cool security tools. That'd be an awesome thing. Mm-hmm. That would walk that line. That would make people happy.
Yeah, it actually.
Your brain's going. I can see you go.
Yeah, I'm thinking about it. Yeah, it actually leads into the next question to a certain extent still. It was more around, reactive versus proactive security tools, right? So like you said, you're collecting all this information. Again, you're using all that information to then react to some sort of threat or hack that comes through later on, right? So how much do you balance the two? Should there be more of a shift towards proactive, and how do you measure proactive success, right? Because security is one of those things that when working well is quiet. So,
right.
I think there's three questions at you, so I don't want to pile on.
Yeah, it was kind of, you're doing it's a fine way of saying that was the premise behind the layer cake idea, is that you're building something from the bottom up. Security shouldn't be just the icing, right? Although I love icing, right? We're getting to the cake analogy. You should have your buttery biscuit base, which you're putting down there, and it's super secure, because building on top of it means everything you build on top of a bad base, be it cake or be it housing or being whatever it is you're building, isn't ideal, and security should be a part of that. The more you do in the various stages in terms of checking static analysis tools, so just looking for OWASP top 10 type vulnerabilities, looking at dependencies for known vulnerabilities, even if you can't contextualize them yet, just knowing you have that in your backlog is easy and effective. And then moving that into the image and then providing context by checking things like YAML or Helm charts to see, am I pushing all of that data I acquired on my way here into something that is a potentially dangerous scenario? So am I increasing the likelihood of risk, essentially, which we haven't defined. Like risk is, most people know risk is impact times likelihood. That's the simplified definition of it. And anything we can do to reduce that is good. So we're talking about likelihood. When we start getting, without data-driven decisions on likelihood, we're just kind of putting our finger in the air. So all that information we get on the layers is all great. We have it and we're ready. And that's where we're making change. And then we start looking at deployment. I know that as risky as this looks, as many indicators of risk as there are here, its deployment almost renders all of that risk highly unlikely. So that's that is where we can sign off risk, and we can even turn the volume down on what it is we're looking for in that context, such that our noise goes down. So this is where we're talking about reactive versus proactive. If I can start adjusting my runtime controls based on knowledge I acquired on the way there throughout the various layers, that means my runtime gets into this nirvana state that you were talking about of just being quiet, because I've turned the volume down where it doesn't matter, and I can turn the volume up where it does. And I can turn it up because those are the vulnerabilities I have addressed. Mm-hmm. So I do not have CVSS score 9.8s on my front end, and because I've triaged in that way.
Mm-hmm. Yeah, you and Larry, I think, are thinking along the same wavelength. Posted, good security is noisy, but the reporting is quiet, right? And I think the tough thing, obviously, is normally when you get these tools out of the box, they make everything extremely noisy, right? Because at the end of the day, it is up to you and your security team to adjust the dials and the knobs, right? One of the things that I find as a challenge is taking, like what you said about risk or noisiness and alerting, and then adapting that to the container-centric focus, right? Because you do have these larger tools, and now it's hey, we did security this way, and we're trying to shift it towards containers. So it's, how do you define risk and manage risk, and all the, let's say, notifications that come with it, right, in a container-centric world?
How do I manage risk in a container-centric world? That's coming back to, all right, I'm going to pick on you a little bit for calling it container-centric world, maybe, because I think right away we shouldn't be looking necessarily at risk associated with the container, because I can run and we've had this conversation before. Good practice would be I can run a container using Docker Compose. It comes up and it behaves, and then I can push that into test. I can push it into pre-prod. I can go into prod, and that's all great, right? And that container could have variety of indicators of risk, from port exposures to vulnerabilities to application vulnerabilities. It could have all sorts of things, but the context of putting it on my desktop renders it zero likelihood of breach, zero impact. It's on my desktop, so risk doesn't exist in that container's context. Mm-hmm. So, but it's that container's journey and where it's going to end up, be it an internal accounting system or be that the front-end identity management system for my e-commerce shop. Then suddenly, the further it gets towards its deployment context, its risk, its likelihood, and its impact goes up. For example, if this is a container that manages access to a database, then its environment variables might have sensitive information to allow me to access that database. Okay, so that's fine. Everywhere it exists outside of production, who cares? With the exception of insider threat, of course. But once it goes into prod, then you start looking at what's the journey to get access to that information. Can I get access directly? No. Okay. Well, then likelihood goes down. Do I have network policies in place that should I get access to one of the front end containers, can I jump directly to that? Okay, well, I can, and that likelihood is high. I need network policies to prevent that, such that there's an elaborate lateral movement that needs to happen to reach there. And then likelihood goes way down. Or I have to pop out of some root container and dig a hole underground through the node and pop up that way. I've got bigger problems than that database if that's the route in, right? Mm-hmm. So that's the way we start looking at what represents risk in a containerized environment. It's what's happening all around it. And that's when you start looking at containers alone, looking at images alone, looking at scanning alone. Any of these methods in isolation can just prove to be theater as opposed to an actual real definition of risk. Well, that was a long answer. Was that all right?
Yeah, no, I mean, I think you summarized it fairly succinctly for a complex topic. I'll say that because, again, containers really, I do empathize with people who, buy into virtual machines to a certain extent because it's the way that we've been doing it. There is a lot of sort of better capsulation of all the information that's going on, the behavior within the virtual machine, right? So containers really shifted that. And then, like you said, you have a database, let's say container, are you injecting the secrets instead of actually building them into the Docker files, because you really shouldn't be in the Docker files, right? There's so many, but then again, let's say you're starting off, that might be the quickest way to do it because you can't set up Vault or something like that, right? There's just all these anti-patterns, and there is no one way to achieve it. So I think it's a little bit of shared knowledge, a little bit of picking the tools and understanding where the vulnerabilities are. But
yeah, I think
we touched on it a little bit.
Well, you just used the word anti-pattern. I think it's funny we call anti-patterns, right? But when we look at new organizations, anti-patterns are the patterns, and they're actually working towards like what is considered a best practice pattern. But it's amazing how so many of these things we criticize as anti-patterns are just what everyone does at the start.
Yeah,
anyway.
And the other thing too is, as a security tool or security team, how much do you allow that to move forward, right? This is just more of a cultural concept of, you're a security team, and at the same time, you don't want to hamper development, and containers allow you to develop a lot faster. So how much do you allow those patterns to move forward without saying, hey, no, we need to actually completely shift this, right? That friction is obviously just always going to be there. And I think it's like led to that conversation of DevSecOps, although partially maybe misused. Yeah, so we talked about a little bit about the communication between humans and that friction. In terms of context when creating security tools, right? So like, let's say you have a Kubernetes security tool, you have a VM security tool. Do you think it's better to have a single tool that manages both, or do you have two separate tools with maybe some sort of collector? We've talked a lot about the context with containers and the context with VMs, so I just want to get your opinion on what situation works better and how do you kind of alleviate that friction between teams, right? Because we almost are getting to the point with the CNCF where it's a tool for a specific purpose, right? So there needs to be, some sort of pane once you get into an organization. It's a single plane.
Yeah. The single, yeah. So I was at a talk when I was traveling around Scandinavia, and there was a guy who came on just before me. Should I name and shame? Should I do that? He was from Microsoft. I'll just say that. But he was really nervous, and he was talking about their new great thing. I think it might have been Arc, but it was, and he slipped up and he said, single glass of pane. He meant to say single pane of glass.
Yeah.
And I laughed so loud. It disturbed the room because he was right. I mean, I made a slide immediately afterwards that had like a glass of Coors Light as my image for the single glass of pane. It was great because that he was sort of correct in what he said. Security people like the idea or maybe this sort of fairy tale notion of a single pane of glass. So a single tool that somehow gives them visibility into everything, but it doesn't really exist. And I think there's a hybrid approach that probably works in a reality a little bit better, because if there's a way of utilizing information, I'll give you go back to the layers idea, right? If I have image vulnerabilities, awesome. But if I'm scanning or running pre-flight checks on deployment, well, it's in my interest to know the image vulnerabilities, not just the misconfigurations by not having security context. It makes more sense that I can see there's a service and there's a load balancer, and it's referencing this application for this metadata, and it's running this Nginx 115, which is like way too old and has all these vulnerabilities. And I know the vulnerabilities. So now I actually am putting image vulnerabilities into context of deployment. That's really powerful. And that should be under a single tooling example. But if there's no point in having something that, if it's not adding to the interface and it's just for the convenience of a single login, it's not always what you're going to want, because it just turns into an impossible user experience, really. I mean, we work with a lot of different interfaces and that's all fine, but I think it's sensible where it matters, it's a smart move. And where it doesn't, it's just a security person's wish list for this single pane of glass idea. That doesn't mean that the industry is not answering that cry for the single pane of glass. If you look at we talk about this all the time, we monitor acquisitions, and you see the consolidation of the tooling market already happening, with big players swallowing up little players, with this idea of bringing them all together into some like platform, and yet then struggling to present what that platform really means. I mean, in my previous life at Synopsys, they did that. They were an acquisition machine. They acquired the company I worked at, and then Black Duck and all these other companies that sit in that space, but it took them ages to present anything that was cohesive and under that one roof. It's hard. So I do think we still require a hybrid as the answer to that. Like the CNCF approach of point solutions is an awesome start. And I think there are great commercial solutions based on some of those open source tools that give you consolidation, which is a really powerful argument for the commercialization of some of those open source tools. So where it fits, it's amazing, but don't overdo it.
Mm-hmm. Yeah, there's a couple other issues too with consolidation, as well as like picking single, applications, especially with the CNCF. Sometimes it's a little bit developer driven, right? So you get projects that were hot 3 or 4 years ago that aren't necessarily in the same position they are nowadays, right? Just kind of a general question towards, those, small tools. Do you find there's a higher risk of silos associated with the implementation of like many small single purpose tools?
Well, I think, I guess there can be silos, but it's not like tools create silos. If you got that, the silos probably already exist in your organization. And that's why the pull methodology of adopting tools, which is sort of the developer preference, that's what happens. I mean, I've been on the dark side of the vendor side of selling tools, where you engage with a security team, for example, and they say, we love it. And then they buy this thing from your organization, doesn't matter what it is. You return in 6 months, and actually the purchase of said tool, be it, doesn't matter what it is, static analysis to a Kubernetes cloud native security solution, all that did was wake the developers up to the fact that, oh, we need something like this, and these guys want us to do this. It's not like developers aren't curious about security. They just weren't involved in the conversation. So now they are. You've already bought it. So they're going to go do their own homework. And it won't take very long before they found that an easily pullable, integratable solution existed in open source, and they're going to start using it. And now you've actually created an internal silo, the competition between security and developers, because the developers have decided open source X is what they really want to use, and they don't want to use that thing you bought. So it exacerbates an existing silo. It can do that.
Yeah. Do you see the future of team makeup to have more of a development where, let's say you have, somebody who's a pure developer, somebody who's more security focused, somebody who's more operational focused, and per sort of microservice approach?
Do I think security, maybe try and rephrase that. Do I think security should be embedded into the existing independence that comes with microservice teams? Am I interpreting that correct?
Yes, that's a better way of phrasing it. Thank you.
No, that's fine. I totally think that's the case. I think when people say, some people have argued that the phrase DevSecOps is just a shoehorn. It's DevOps. If you look at various definitions of DevOps, some, I think it was the Microsoft one, actually says security is part of this. It's the integration of everything to make sure that it runs for a specific purpose, and security is accounted for. The only reason it isn't, or often isn't, I should say, is just culture and education, and to an extent incentive, because we don't really, in the organizations I've worked for, where I have the privilege of talking to development organizations, and I say, well, what is it? What are your incentives? What are your team? And they say, oh, well, our incentives are to reduce our build time to 15 seconds. All right. So there's very rarely a mention of making sure our team produces the most secure code when it gets to the point where those checks come into play. There's no there wasn't reward, or there's a carrot around that. So once we start to educate around that and provide that as part of the culture, and I think university and the way we train at the moment needs to be a part of that, then it'll just happen. And some of these problems we're talking about of having silent security or out of band, or all the measures that security teams have to do at the moment to try and tiptoe around this velocity model, hopefully will get baked in a lot easier. See, it baked in. I got it back to cake.
Yeah, nice job. Really, really leaning on that. Yeah, it leads into somewhat of a larger question, specifically around bigger companies that have this set framework around how work gets done with the essential objectives that you pointed out. How does a security tool that is more specific to containers and Kubernetes with that context, what is the typical friction associated with an adoption like that?
Okay. I don't think, if I put it in the context of the way you worded that, like a Kubernetes native security solution, the friction, because you kind of left friction wide open for me there, which, thank you, I like that. The first step of friction, which is what people don't think about, is financial. It's budget. People probably expect me to say, oh, developers won't want it. And I think you actually have an easier time. If you go to developers who love cloud native and love Kubernetes, and you say, I bought a tailored Kubernetes security solution as a security person, oh my goodness, they'd be like, oh, you're amazing. You're actually providing us security in the language we like. So I think you'd do better there than you would, most security teams would do. But where you're going to find resistance from the outset is when you turn to the CFO and say, yeah, but it costs X. And they go, didn't we just buy the VM security solution like last year that costs us our entire budget? Like, how do I justify this new budget for this new thing when I have the budget already being spent on the other thing, the old thing, and we still have legacy systems? So prove to me I need this new thing. So that I think is like the very, very first step of friction when you're trying to go cloud native security. Like, unless you're cloud first, in which case, great, your budget for security is you didn't have any legacy security tools or incumbent things that are legacy taking your budget away. But if you're talking enterprise, you're probably not brand new, right? You're like a financial institution or something. This is a struggle.
Mm-hmm. So financial first, let's say you do get the budget and now you have two tools, right? One for virtual machines and one for Kubernetes native. How would you sort of bring those contexts together? How would you manage something like that?
So the next level of friction is scale. The more touch point, the more people have to be involved in your security solution, the less likely it is to succeed. And then beyond that, the more actual engagement, let's say adoption, like must-have adoption you need, even less likely that it will succeed. So this is why, going back to the static analysis analogy, if you expect everyone to use a static analysis tool, and actually if you require it, probably never work. It almost has to be optional, but then you need a compensating control later on to make up for the fact that some people didn't do it. So we're going to check that out of band, perhaps in CI, but the people who embedded it into their IDE, well, they have massively changed your risk posture. So that's great, but it shouldn't be required. A great example of this where it never works, and we talked a little bit about this at our meetup last week, is supply chain for tools like Intoto or some of the new ones that are coming along, right? In order for that to actually work, every single developer has to use it for every touch point on the software, thus making it almost an impossible tool at scale to prevent breaches of that style. So that's your next level is, can I scale this in a frictionless way, in some way, and then expand it and take additional advantage as developers create additional touch points with my security solution. If you can do that and you have a model for scaling your security that adheres and acknowledges that, then you're off to a flying start. That's really good.
Yeah, and obviously that seems to be sort of the push for that shift left, right? But really what we're talking about is security checks closer to the developer as part of the build or deploy pipeline, right? If you can do that in an automated way with maybe more of a focus on engagement and knowledge transfer as to why the check's happening, instead of just like a, hey, you're bad, stop it, right? That seems to be the goal when you're talking about scaling, right?
Oh, if you get to that point, then you absolutely nailed it. Like it
really. Oh, sorry. I think my internet's going very poorly today, but yeah, no, I think once you get to that point, it really smooths a lot of things. But that's really only been available as an option because of this supply chain that a lot of companies have set up, and also the declarative nature of a lot of code nowadays, right? With version control systems and CI pipelines. Without those original technologies, you wouldn't really have that capability. So, little quick question as to, where do you see the future of that declarative nature of code, and how do you see it spreading across the different layers that you've outlined?
Yeah, I'm a huge fan of the declarative nature of code. I find it funny that that it took us so long to get there. I mean, when I used to write Perl scripts when I worked at Nortel, that dead company, that was designed to do what we're trying to do now. Infrastructure as code, but Perl script is a logical coding language. It's not a declarative language. The idea of a declarative language was kind of it was sort of forming, but didn't really exist. And when now we've got, JSON and then YAML and then a variety of other methods across the layers, whether we're talking Terraform, that allow you to say, this is my defined state. And then I allow something else that implements logic to maintain that state for me or establish that state, and thus allowing me to check that state in advance. Like, this is a huge leap that we're all adopting this sort of method of thinking. But I feel like, and feel free to debate me. I'd love to get somebody on my podcast debating me about this. The idea that we get really excited about GitOps, like the idea that now I've got my infrastructure of code and I change the code and it automatically gets deployed and state is maintained by Git and change control and observability and a single source of truth is great. But if you translate that back to just application code, that's what we've been doing the whole time. We've been writing application code. We've been putting into source code control. We've been making subtle changes. We've had approval workflows. The result means it gets built and it gets deployed. Like, that's not a new concept. But now we have declarative definitions of infrastructure, and we're doing the exact same thing, like with slight changes, just because it's infrastructure and not logic. And now we're all singing and dancing the GitOps song. But it's the same thing, just with a new buzzword. And the fact that we think it's exciting and new is like, all right, well, great, let's do that. But it isn't really. It's just a redefinition of an existing pattern, and it's good we're doing it. And I think because security existed in the application first, like I said, people will start to realize that actually all the same checks apply. If I bring up YAML in my VS Code, there should be something telling me that I've missed my security context. I don't even have it in here. Something should be telling me, a little squiggly red line should be say, hey, you haven't got this here at all. Or all the same checks that I would expect to identify the potential for SQL injection in my application code should be doing the exact same thing when I'm looking at Helm or YAML or anything. All of this world should happen. It doesn't happen quite yet, but it's awesome that we're moving towards that, because that is properly shift left, properly proactive, and that's going to mean that when we start looking at runtime, we are seeing quiet now.
Mm-hmm. Yeah, and I think as we get those noisy applications, we get more into the ML world, right? Like, once people have had defined Kubernetes applications for a year or 2 or 3 years, in your version control, you're going to have some sort of defined configuration as well, right? And so then you can start to look at baselining against your actual declarative state, right? So somebody goes in and maybe messes around in GitHub and changes some sort of port, right, in your YAML files, you'll automatically be notified of something like that, right? Because you do have this baseline structure. So I think that's more of the maturity model around, that sort of declarative code that's come up. Really, at the end, I sort of think it's just getting more into observable. I use observability a lot because it's always used in monitoring, but really, I think it applies so much more to security to a certain extent, right? I think the declarative nature has changed how we approach, security tools and the state of security of our applications.
Totally. Yeah, you're on it. Like, was it earlier you said, or maybe it was one of the people in the Q&A said something about the good security is noisy, but the reporting is quiet. Was that you or was that somebody? That was a great quote. Because
Larry in the chat. It was awesome.
Oh yeah, that's perfect, because if you were to look at raw eBPF output, like that's a mess, right? That's noise. But it's how a security tool translates that into actionable data that is the reporting element that is really critical. And I think this understanding of declarative information, if we bring all that in and we factor all that into what is turned into actionable information, then our observability is proper. We're not just saying observability via opening the floodgates for everything. Observability is not looking at your eBPF output.
Yeah, and I guess one of the things I grapple with daily is because you're pulling and extracting so much information and also doing basically a lot of formatting, you also have to make sure that the team that's developing the tool also knows what they're talking about too, right? If you have somebody that has a specific mindset for a specific output, they might not understand the final phase, or you might actually get something lost in translation, during that formatting too, right? So I actually think that supply chain isn't necessarily always just about access or identity management. It's also about basically the ETL process of how that security specific context information gets to your doorstep, right? Is it raw? Can I filter through it? Do I have that capability, or is somebody doing that for me? Right? Those are I'm not sure if you had this built into your layer, but I think the sort of transition of information towards the end user also matters a lot. Haven't quite figured out the impact though.
Well, the stakeholders need to be taken into account. A good example is a lot of security tools present, let's say they have their own dashboard or they have their own pane of glass, whatever. But it doesn't change depending on the stakeholder that's viewing it. It needs to be relevant the information needs to be relevant for the end user. And if you're talking about DevCentric shift left, and the reality is runtime information, a lot of it is relevant for all the way back to the beginning, the shift left. So you want them to work shift left. They'll do as much as they can, but there's something has changed. You have a deployment, there's a new vulnerability, and it's in my deployment, which means it's in an image that my development team is responsible for. You need workflows that send that back, but the information that travels with that, well, it can't be a login to the dashboard and see it. There's got to be a tailor-made workflow that puts it into a Slack channel with the information you need. It speaks the language and the tooling that the developers require. And that's a real struggle for tools, to make sure that the tool vendor understands what's the destination for this information, who's it for in the first place, and let me deliver it in a way that speaks their language. That's a real struggle. Yeah, if that's where you're going.
Mm-hmm. Yeah, and I think that as much as things become standardized, or let's say their outputs become standardized like YAML or JSON, there's still a bunch of different ways that people actually consume that information, right? With so many different contexts. So when you're talking about stakeholders or who's actually getting the output, I think that is kind of the core concept, especially with honestly a lot of applications, right? In the end, it's business value, and I need to sort of convey the security state of my solution or your basically system through my solution to you in the best way possible, right? And yeah, it's just because there's so many different options, and you have different clouds, different providers, Kubernetes, VMs, bare metal, right? bare metal has become an interesting conversation the last 5 years. I think that the context matters so much because, to be honest, security and tools move so fast that I actually think that's where you see most ROI, most of your return, is because if you can implement a security solution, doesn't necessarily mean that you're going to get the most bang for your buck out of it, right? If one, you don't have adoption, or two, you're actually not even getting the right context, right? So I think layer 8 should be funding and money, something like that.
Okay.
Should be. That's what you gotta. Because I mean, it is a big return on investment, and the C-level, the executive decision, I think matters a lot too, right?
Maybe that's the real icing on the cake.
Yeah, there you go. Right back into food again.
Yeah.
Cool. Any last comments? Any last questions in the chat for Steve before we head off? Steve, anything you want to pass on to the people watching? Anything you're doing, interested in watching?
Interested in watching. I'll make one comment we didn't really touch on, which I think was something that really stuck for me with our conversations we've had with Jessica Cherry. Was she's got a bugbear about tribal knowledge, and something I probably should have mentioned that is a real plus of a declarative nature, both security but just anything ops, is that if you've got a tool that, if you recognize that this tool will eliminate tribal knowledge in my organization, or this method or this language, that's probably good. That's going to save you money right away. So that's, if you're looking for where to start, that's a great question to start asking yourself. How can I eliminate tribal knowledge? Well, if this tool that analyzes Terraform is going to make sure that everybody uses Terraform, and it's going to check and it's going to ensure that it's all correct and we get down that path, and therefore I don't have one person who knows how to set up my cloud, amazing, do that. So I was a big fan when she had her slide up that had superheroes on it, and she was kind of anti-superhero.
Nice. Awesome. Yeah, Jessica Cherry, and she's part of the meetups as well. Really a big fan of breaking clusters. So yeah, check her out. She does some good chaos engineering work. So cool. We have no questions in the chat for you.
Too
Steve,
thorough.
thanks again for joining. Anybody else that's watching? Too thorough. Steve, anybody else that's watching, the recordings will be sent out after. If you missed anything, feel free to share. And thanks again for joining. Take care and have a good Friday and rest of your weekend.
Thanks.
Bye.